going because we got a lot of material to cover. Okay, now that we did that, I want to do aha. We'll do over here. Sean, if I write over here, can you see it? Yeah.
Yeah. Well, now we started 15 minutes late.
Okay. I've seen this on every version of every test I've ever seen.
That exact one?
This exact one. Hold on, I haven't actually given you the problem. I've just started to write it. I wanted to preface it with that so you all listen. If it's not, I've seen it on every single one. So if it's not on test 4, I've seen it not be on test 4, but then it's on the final. Does that make sense? So you're going to see it either now or on the final. I've never had a term where it didn't happen. And even if not, at least they won't trick you on this one. You guys with me? You're all focusing? Okay. They give you this, and they say find dz del x plus y del z del y. Now, first of all, this is tricksy because they've never had you do something like this before. And second of all, they're using weird notation. Let me tell you what this means. This means x times f sub x plus y times f sub y. We all good? We all together? I can tell you guys, ambient level of fear has risen. It's quiet. I'm feeling a lot better, which I'm really excited about. I was so sick. I hate being sick. Sick sucks. Kind of obvious. Okay. So we're going to rewrite this to the 1/2. And I'm going to take the derivative of this. I'm going to take the derivative with respect to x and the derivative with respect to y and then plug them in. And hopefully it will be clear what I'm doing. So if I take the derivative with respect to x, the 1/2 comes down. The x squared and the y squared stays the same because I'm doing chain rule right now. You subtract 1 from the power, I get a -1/2. Multiply by the derivative of the inside, which is 2x. Okay, I'm going to breathe for a second. Everyone can see? So far, so good? It's a tricky problem, but you can handle it, especially since it's always the same. Okay, I'm going to simplify a little bit. I'm so blunt, isn't it great? Okay, that's f sub x. I just simplified. Everyone following? I'm bored. But I'm happy to be here. I just do the same problems over and over again. On the bright side, I know that I'm doing them right, and I know you're going to see them because I've done them that many times. The 1/2 comes down again. We leave the inside alone. We subtract 1 from the power. We multiply by the derivative of the inside. And then we simplify. It's exactly the same except for there's a y on top instead of an x. Okay, you guys ready for the trickiness? The trickiness is coming. Oh, I don't want that one to go up. I want this one to go up so I can stand up. Okay. X times this. Y times this. I'm going to go down to the next board so that I don't have to cramp. Because when I write small, it's the same as not writing at all. Because I always have to just redo it. Okay, you with me so far? Okay, x times x is x squared. Y times y is okay, they have the same denominator, the exact same denominator.
So we can add them. Combine it.
I'm a little bit afraid they've gotten wise to tell you the ridiculous problems they put on there. But if they have, maybe that means they got rid of them. So you only have realistic problems, like you've seen on your homework. I'm okay with that. Okay, this, can I explain it? I want to, yeah. I would like you to see what I see, and I'm going to hope that if I write down the next step, you'll see what I see. Do you see what I see?
Yes.
The top and bottom are the same with different powers. How do you simplify it? Top minus bottom. So this would become, my 2's are starting to look like Z's. And that kid in the front row is going to have his happy day when he says, I told you so. Okay, so far are you with me? Do a little loop. Okay, and now here's the kicker.
Oh my
Gosh.
That's the kicker, right?
Oh my god.
Oh my. It goes right back to the beginning.
You guys see it?
Yeah.
Okay, you see this problem? You just write down C. You see? Yeah?
We see.
What's the answer?
Why do we do all that work?
They're tricky. They'll have things like Z, Z to the 1/2, Z squared, 1 over Z, 0 and 1. 8th Amendment? Hey, I'm telling you the answers. How is that a bad thing? Okay. We need to go on and do the rest of the tests that you need to know the answers for, yeah? So I'm going to just keep going.
That was pretty funny.
I think it's maximize the product.
That was pretty funny.
I often use that as grade school. 0. I always do. Everybody else plays
I had those memorized.
Do I need to not write in the shadow? Is that the problem, Sean?
You're okay.
Okay, this is one I would pay attention and maybe know, just maybe. Pretty much everything I'm doing tonight is something you should pay attention to know. That's kind of the point of tonight, right? Okay, are you ready? I'm ready. Great. First of all, you need to be able to tell the difference between the big D and lambda. Big D only gives you one equation. Lambda gives you two equations. Look, I see two equations. I guess we're doing lambda. You see? I feel like I'm doing like sharing time and no one's paying attention. Maybe we should have snack time. Okay, what is your question?
With the word problems with these ones, Minya always did substitution. Are we supposed to use lambda or will we get the same answer? Or?
What do you mean substitution?
Like he would just like solve for y and like put that in like.
And take the derivative afterwards? That's bad because on the test you can't do that. There are 3 variables and you can't solve this without knowing how to use lambda.
Okay. No, like, but on the word problem stations, same thing.
This is the word problem.
Oh, okay.
Do you mean like a box one or something?
Yeah.
We can do that in a minute.
Okay.
I don't think there's going to be a box one on the test. I don't remember. I didn't ask Minya specifically. Okay. Maximize the product of this and that. Okay. So we say f equals 3x plus 2. No, I lied. We want this one. xy squared z cubed minus lambda times 3x plus 2y plus z minus 36. Okay. I'm going to write down the steps you need to memorize over there. And then I'm going to let you guys work on this while I write down the steps. Goodbye, salt. So you guys know Dr. Seuss books where everything's like written all crazy? Last semester I was taking differential equations, this is like the first day of differential equations. And they had a salt problem that looked like Dr. Seuss illustrated it. I was like, there were like 3 in this way and 2 out this way and they're draining out different areas and I was like, I would like to I don't care. I don't care how much salt is in the tank. I had sympathy for you at that moment. Okay, steps. I think you need to identify the
Dude.
um,
So we need to memorize these, right? Oh. What's that? No,
Short
nothing.
of what?
No worries. We need to memorize that, right? That should be. Yeah.
Okay, I'm just gonna say that that's right. Okay, we need to take all of our first order derivatives. Fx equals y squared z cubed minus 3 lambda. Fy equals 2xy. Z cubed minus 2 lambda. Fz equals 3xy squared z squared minus lambda equals 0 equals 0 equals 0. Move out of the way so you can see. Okay, I'm trying to go from hardest to easiest, so at the end, when you're all burnt out and dead, you're going on easy stuff, so you're ready for it.
I think that's a good method, by the way.
Yeah? So far, so good?